Hi there, this is Jacob Nash, Precalculus Lessons, and this is Unit 3, Lesson 4, on solving logarithmic and exponential equations. So, how do you do this? Well, let me zoom this thing in a little bit. First of all, exponential, you sometimes want to make the bases the same. Usually that's not possible. In most cases, you have to use the log or ln natural log function on both sides to move the exponents. And then for the logarithmic ones, we just want to isolate at x, and you might have to get rid of the logs, but you can't really say what you have to do for every one because it can be a little bit different. So let's see what we do for the first one. That's kind of a general idea, but it's different for everyone. So for number one, we see that there is two different bases that we have. We have an 81 base and a 1/243 base. And obviously, they're not the same. You can't always make the bases the same, but in this case, you can, because we know that we can get 3 to 81 by making it 3 to the 4th. And 243, well, we know that we can make 3 to 243 by 3 to the 7th, and you actually might not know that. So if you don't know that, then you would have to use a calculator to figure it out. But we'll see in a minute what you do if you don't know how to make the bases the same. But since the 243 is in the denominator, we need to make it a -7. So now our bases are the same, but don't forget we add a 2x here. Now we get rid of the 3's because they're the same. And we can do 4 and distribute that to the 2x. And we get 8x equals -7. Oh, that's wrong. It's 3 to the -5th, not -7th. And x is then 5/8, -5/8. And I think I put, well, at least I was supposed to put the answers on here to make sure that I got it right. But for some reason, I don't see them. Oh, well. But I know that's right because I remember. All right, next one. Well, in this case, it's not really possible to make 3 and 5 the same without doing something super crazy. And we're not going to do something super crazy. But what we can do is use our rule. So 3 to what equals 5? That's what we're trying to do. Let's just say we want to make both of the bases 3. Well, we can't do that in our head because that's not going to be a normal number. But we can change this to the form log base 3 of 5 equals x. So that means this is what we can plug in for the exponent. So in other words, oh, actually, that's not what I wanted to do. That's if we wanted to make both bases 5. We can still do that though. But basically 3 to the exponent of log base 3 of 5 is the same thing as 5. How do we know this? Well, when we have something like that, we can cross out the 3 log 3, and then we just have 5. So that's what we can do. So we have 3 log base 3 of 5. That's going to have to multiply by x plus 2. And then we have 5. Or sorry. Oh. No, never mind. I mixed it up again. That is if we were going to make both bases 3. I got mixed up. Sorry. Okay, let's start that over. So 3, if we're making both bases 3, that does equal to 5, but both bases are going to be 3. Sorry. And then that's going to multiply by 2x plus 3. So now both the bases are 3, but we haven't changed the value of anything. This is still 3, and this is still 5. So now we cross out the 3 since we're done, but this is going to get a little bit complicated, and we need a calculator for this one. We distribute the log base 3 of 5 to the 2x and to the 3. For the 2x, we just get this, and we're not rounding yet, so we don't solve it out. And then plus 3 times log base 3 of 5. Now we subtract 2. And let's put that into the calculator. Log base 3 of 5. Well, let me see. Do I have this Wabadimu thing on here that I showed you the other time? Let's see. I don't know if I have it on here. Oh, I think I do. Okay, so let's use that so that I can show you. Okay, why won't it, if I go to this, oh, just because I was full screened. Okay. Let's plug this in. It's going to take longer for me to do it on here, but sorry, that's just what we do. Okay, so we're going to do log. Let's not do that log because we need to do a base. So math, and then we need to go to log base 3, 5, and then that's got to be multiplied by 2x. Wait, what? Oh, yeah. Oh, no, sorry. That's not what we do. I forgot we had an x in there. We can't do that yet because we don't know what x is. So we're not dividing by 2 yet. I mean, subtracting by 2 yet. Instead, we're subtracting by this x. This is a value of x. So we need to have x minus log base 3, 5, 2x equals this thing minus 2. Then that's what we do. So we have to figure out what that is by doing 1 minus, I just need to enter this down so that we have more space. Okay. So this looks a little bit complicated, but all this simply is we're leaving it like this because this is such a strange number, but this is really just a number like something times 2. But let's figure out what that is. Let's go to the calculator. So right here, there's no coefficient that we see, so we're saying that's 1, and we need to subtract that minus log base. So we need to go not second, math. Then 3 base 5, but remember, also times 2. So now we got negative 9.29, but we're not rounding yet, so we need to just leave it with dots x. So this is our coefficient of x now. But we still have this on the side that we don't need to solve out yet. And calculator is blocking it. Then we divide by this number that we just got in the calculator. To get what x is. So we go into the calculator. No, I don't want to go. And we need to do, let's make it simpler and have a fraction. So alpha y equals is how you do that. We want numerator, denominator. 3 times, we have to do log base log base 3 of 5 minus 2, and then we need to do divided by, we go up to this number and we push enter. Uh-oh, I did it on the wrong thing. There's not an undo button on this, so del. I wasn't on the denominator part yet. All right, let's go down. Let's make it to where we can see the whole thing. All right, now we're on this. Let's just do ands, A and S. That gives us the answer. And we need to do, see the blue ands by the negative symbol. We get second minus symbol to get ands. So that means our answer that we just got, which was up there. Answer, we have negative 1.241. And that is the answer. I already checked it before. So that was kind of a crazy problem. So that's if you can't make the bases the same. So let's face it, that might have seemed hard to you, but it's better for you if they're able to be the same. If not, you have to do it like this. But usually it's not that complicated. It was just because we had an X on both sides that was kind of crazy. Okay, this kind of put everything out of alignment, so gotta move this stuff back. All right, the next one shouldn't be as hard. All right, this one's not an exponential one. But on these, we got to make sure that whatever answer we get, we check to make sure that it doesn't make the argument, which is the thing in the parentheses, negative. Because if it does, then that's not a solution. So what we know, remember we had our rules that was on the last video, pretty sure. Since these are being added, these two things, we need to multiply their arguments and to make it 1. So now we have x times x plus 20 as our argument equals 3. So we don't have a logarithm on both sides, this thing. That's not on both sides. So we can't just get rid of this thing. Instead, we use our rule knowing that this base to this power equals this. So in other words, 5 cubed should equal our argument, which was x times x plus 20. And that it does. So now let's do, we can put, I'll just switch the sides. I like my x's to be on the left. So we distribute the x and we get x squared plus x, or 20x equals 125. Okay. Now let's scroll down a little bit. Let's make the 120, we're trying to find x, remember? So let's make our 125 on the other side so we can factor. If we couldn't factor, we'd have to use the quadratic formula. Remember that thing? But I know that we can factor this. So now, whoa, this is a little bit of a tough one. What two things multiplied equal 125, but add equal 20? Well, it's actually 25 times 5. You might have been able to think of it, maybe not, but any number that ends in a 25, 50, or 75 usually can be divided by 25. Let me see if that's always the case. Yeah, it is. So if we know that 25 times 4 is 100, add another 25, that's 25 times 5, and that's 125. Okay, so 25 times 5, and we need to make a positive 20 and a negative 125. Let's do this. Okay, then we would find that x is negative 25 and 5, but we have to check our answers. Remember, we have to do that because sometimes it might make the arguments negative. So let's figure out what would happen if this oh wait, sorry, I forgot to scroll up on here. What if that argument was plugged in with negative 25? That would be a negative argument. So we already know negative 25 doesn't work. Does 5 work? Yes. But what about the other argument? We plug in negative 25, we get negative 5. Doesn't work. Plug in 5, we get positive 25. Does work. So 5 is a solution, but negative 25 isn't. So we just scratch that out, and we only have 5 as a solution. Usually there's only one solution, and usually the negative one is the one that's not the solution, but it's not always the case. But okay, now let's do this one. I did that one a little bit slow, so let's try to do this one a little faster now that we know our rules. So we need to combine our logs. Since there's a negative right there, they need to be divided. So log with base of 9 has 3x minus 2 or plus 2. And then let's just change that to negative 4x plus 7, just rearranged it. And then log base 9 of 2. Now, this time we have logs on both sides, so bye-bye, they go. Now we have this. How do we find x when it's in a fraction like this? Well, we can use proportions. Well, not really proportions, but the cross multiplying method. So that's 2 is really 2 over 1. Got that from there. And that means we multiply those and those. So we have 2 times negative 4x plus 7 equals, and then times 1 is just itself, so 3x 2. And then distribute the 2. And from here, we should know what to do. We add 8x. And then subtract 2. And then x is 12/11. Got to plug it back into the argument to make sure it works. 3 times 12/11 is, or plus 2, do the whole thing, 5.27. We can do that. That's as long as it's not 0 or negative. 7 minus 4 times 12/11 is 2.6. That also works. So that is a solution. Sorry, I forgot to scroll down again. I'm doing this on my iPad and then recording with my computer since my iPad's messed up. So that was the solution. Okay. Now we're doing it again. We add these so they're being multiplied. So then you subtract x, and that equals 2. Oh wait, we have to have the log here. Sorry, log base 2, and then that is just 2 there. This time, there's not a log on both sides, so we have to say this to this power equals this. So 2 squared equals, let's go ahead and multiply this out. That would be x squared minus 10x plus 24. Divide by x. So this one's a little bit tough. That will be 4. We can say 1. We can cross multiply. So 4x equals, forgot to scroll again, sorry. So this is, here I got to the proportions, and well, not really proportions, but you cross multiply, and that's what I did. And now I'm writing down the other side. Now, since this is quadratic, to find x, we'll need to factor, so everything has to be on one side, so we set it equals 0. Okay. All right, now that'll be x squared minus 14x plus 24 equals 0. We can factor that by, let's see, 12 and 2. Both both negative. Okay. So then our solutions would be 2 and 12, but do they both work? Let's see. 12 minus 6 is 6. That works. 12 minus 4 is 8. That works. X 12, that works. And then 2 minus 6, -4. So sometimes positive ones don't work. So this time 2 doesn't work and only 12 does. Don't even have to go any further. So x does not equal 2, it only equals 12. And there you go. That is how you solve problems like this. Thank you for watching, and I'll see you in the next video.